Here as a modern golf group, I'm Bradley Rankin.
I'm Brendan Blakeney.
I'm Kate Wallace.
I'm Tyler Sample.
I'm Justin Devine. Our project sponsor is Ken Luno. He's an architecture manager or lab manager over in the AMU building. And what he was looking for in this project was a golf cart that have the golf amenities on it and also have some amenities for just town festivals and recreational use.
A little bit about project motivation. Golf carts were invented around the 1940s and 50s, and since then, all that's really changed on them is going from 3 wheels to 4 wheels. They all kind of look the same, they're boring. So what our sponsor wants is a unique and eye-catching design that goes fast and you can use while traveling around town and golfing, while also having all the modern amenities needed to do those things.
So our main objectives for our project is, in the end goal is to have a professional level craftsmanship for the golf cart. Safety is a priority for us. We don't want any of our operators to get hurt while using the vehicle. And then a couple of restrictions or goals that we have for the cart is a speed minimum of 30 miles an hour. We want to increase range for golf, and then also getting home and other activities with that. We would like to have a golf and a street mode. So actually the speed on golf courses is roughly 14 miles an hour. They kind of limit you to that. And then we wanted to just have a switch so that you can flip between those 2 modes. And then Bluetooth speakers, larger wheels and tires to achieve that speed goal. We would like it to have an overall unique design, like a 1-on-1 cart. And then lithium-ion batteries or lithium phosphate batteries for fast charging, low maintenance, and then an overall good environmental impact. Actually, we'll go back. This scan was actually used from a phone LiDAR scanner. We're kind of looking into doing a different scan. We have the scan done. It's just kind of a process right now. But our goal is to use the scanner to get a model so we can draft on it. We have plans for redoing the back of the cart. So for our state of the art, there are not too many companies that are doing full redesign work that we plan on doing with the cart, such as speed permits and adding those different amenities. A company that does do stuff similar to redesign is a company called Golf Carts at Cypress, which is what this picture is. Most people, when they redo golf carts, they kind of just lift them, put larger wheels on, and use them for base transportation. So a lot of them add just rear seats, and they don't really add amenities that we're going to add. Generally, Bluetooth speakers and wheels and kind of things that are found on golf carts. Our first main addition that we're looking to add onto the cart is a cooler. This is our design matrix for this decision. We came up with either adding no cooler and just using what the golf country or the golf course will give you. And then second option was adding a standard ice cooler. And our third option would be adding an electric cooler routed in with the battery of the cart. Our four criteria was cost, energy efficiency, cold time, and maintenance. And we ranked all of them and ended up coming out with the standard cooler and electric cooler. And after further discussion with our sponsor, he really wants us to get an electric cooler working on the cart.
Here's our design matrix for the storage in the back. Our 3 options we broke it down to was no change and no cooler. So we could just where that the clubhouse provides or whatever Ken would want to bring. Half cooler and half storage. We'd split that picture on the left in half and have one half be cooler, the other half be for storage. And then we went with either all storage and small cooler on the side. So we'd have a smaller electric cooler that we'd buy, we could save money, and then expand that back storage, to the width of the cart. Our ratings were based off of cost, looks, and size. And we chose to move forward with half cooler, half storage, or all storage, and small cooler. This kind of depends on body kit that we just bought. That'll be here sometime this week, that kind of dictates what our decision will be.
Our third design matrix was the dash for the golf cart. We had three options: no change, aftermarket dash, and a custom manufactured dash. We decided to go with the aftermarket dash as it seemed the most reasonable. No change. We left the cart looking boring, and the dash kind of useless. It's just a big storage space, really. The custom manufactured dash wasn't feasible because it was really expensive to manufacture that dash. So we actually went with the aftermarket one and have that ordered already.
As Tyler was saying, we went with an aftermarket dash that we purchased and is on order. Shown here is the same model dash that we have on the way. The top lid flips open for extra storage up front for the driver and passenger. We plan to add some golfing accessories such as the ball holder that we designed shown below. Most people that do cart upgrades take away those golf amenities and add back seats and use it for everyday use. But we're looking to add those as Ken wants to use it for golf as well. And then like Kate was saying earlier, with the adjustable speed to have on the course and then being able to turn it up to drive on the road. Here's a dial controller to adjust the speed, acceleration, and regen. So that'll be hooked up to the motor controller and the battery. So it will have variable current to adjust that.
Our first main design calculation we made was reaching that top speed of 30 miles an hour. We took the rotational speed of the motor and the radius of the tires and divided that by the gear ratio. Currently, the stop ratio on the cart is 12.3 to 1. And we looked into a 10 to 1 ratio, an 8 to 1 ratio, and a 6 to 1. And then we're also looking at increasing the tire size. Here are our numbers that we got. As you can see, with the stop ratio, it's kind of right in between that 18, which is the stock tire, and the 20.5. We're also looking into other ways to increase the speed without having to do other things, such as programming the controller and adding a small lift kit onto the cart.
As Justin was saying, we are going to be upgrading the motor to reach those speed requirements. So this is the motor we chose. It's a Navitas 5 kilowatt motor, which produces about 7 horsepower. This is an AC motor, so we'll be replacing the current DC motor on the cart with an AC motor. Some of the benefits of doing this, it increases the speed and torque of the cart. This specific one has the adjustability, like I said earlier, with the dials. The controller is also programmable from your phone with an app. So we can actually increase the max speed of the motor to help increase the max speed of the cart. And some other things can be reprogrammed. AC motors are also more efficient. With the brushless motors, it can produce less heat. There's a few really cool things that you can do with the phone app as far as programming and even locking out. So if you have grandkids or even younger kids that want to drive the cart, you can lock the max speed. So when they turn the dials, it actually won't adjust to that. So if they crank it up, they'll still be safe as long as you have the lock control speed setting.
Another calculation we had was our torque calculations to stay at a constant velocity of 30 or above. The numbers and colors are torque numbers. Those are in Newton meters. To calculate it, we summed the forces, and those two forces were drag and friction force of the tire, or the rubber on concrete tire. Our total weight was just over 1,300 pounds. So that was our friction force, and then our drag force, we assumed a square front. Yeah.
For our last calculation was like a power, budget calculation. On the left, we have two different batteries, a 105 and a 150 amp hour battery. Kilowatt rating is just based on the amp hour and the voltage supplied to the battery. Which basically just determines how much battery you actually have. We had a base assumption for an energy consumption rate of 0.06, but we added on a factor of 50 feet for additional weight and of the passengers and load. So using the kilowatt rating and then the energy consumption rate, we did a range estimation for each battery, and then with our two different modes of travel or use for the cart, we have golfing and then driving around town, which is Kent's limited use of the cart. Summing up the items with the amount of runtime estimated, you can get a watt-hour rating, and for golfing is roughly just under 3,000 watt-hours, and then for driving around town, it's roughly 6,200. So kind of going off of the rating for each battery, it's wise to go with the 150 amp hour battery.
And then here's our Gantt chart, which kind of just shows what we've been doing lately. Our main focuses right now are the final design solution, our advertising video, and then ordering parts for our cart. We're going to do that over the break. And we just started disassembling the cart. We got some pictures of that, but we're just trying to figure out how to make that storage in the back a little bit deeper and wider without affecting our other equipment.
This is our budget. We have normally all of the materials we'll need to build the cart already updated in our budget. So for right now, what we have ordered, we actually have the cart in person as we're taking it apart. We decided to go with 150 amp hour battery for the increased range and things like that. A couple things that we've already ordered. We've already ordered the body kit as well as the dash, as those determine some of the designs we're going to do for the storage and cooler. So we need to get those here to really investigate how we can modify those to make those things fit.
Okay, so for those of you who are in class with this team every week, you probably had a chance to ask them a lot of questions already, but some of you are just seeing this for the first time. So let's hear some questions for this team.
For your charging, well, what the connection are you thinking for charging? Like this Tesla-like connection since it's electric?
So most golf carts have a charge plug in them, electric carts built in. What we want to do to make it easier to charge anywhere, we actually want to build a charger into the cart, so we can have that under the seat or somewhere like that. And then it can be just plugged in anywhere with an extension cord. So anywhere you have a plug-in, the cart can be charged instead of having to carry around the specific charger that only works in that plug. Okay.
Is it a street legal or like how are you gonna manage? Like, are you gonna have to get licenses and registrations for it?
So yeah, there's not actually like a street legality for golf carts. There's low speed vehicles, but it's not exactly that either. The way to go about it is to actually follow the city ordinance that's going to be in. Ken lives in White, South Dakota, so he has to go and basically just get it approved with the city, and then he gets like a permit to ride it on roads. So yes, we are planning on ordering like headlights, taillights, blinkers, mirrors, and stuff to just make it safe on the road. But those all follow the city limits for golf carts.
What does the drivetrain consist of? Because you talked about it, changing out the electric motor and then gear ratios and whatnot. Is it an open drive system? Is it transmission, or what does the drive system look like?
So the motor It's connected through one gear, just a one reduction. So the motor's actually mounted to the rear end. And then that one gear ratio is the only reduction in that. So,
So it's all kind of unitized and.
yep.
I'm just curious, like, what's the price of the regular, like, golf cart and then the price of your, modernized golf cart? So what would be the, like, price, cost effectiveness or cost effectiveness in terms of the regular and the modern?
So used golf carts roughly go for, there's a large range, probably anywhere from an older model would be 2,000, 3,000, and then the newer models would be anywhere from 10 or a little bit. For custom carts, it's kind of also the same way, depending on what you put on it, but like 16,000 is a fair estimate for a custom cart. Assuming all items and labor.
The food cart actually costing almost 12,000, right? So kind of if we compare it with the custom cart, then it's still cost like efficiency, right? Very good.
What's the brand new boring?
They're about around that same range, 15, 12, 15.
Brand new custom cars, so they usually are about 15, 20. But they don't have all the accessories.
Real quick, can we go back to the power budget? Can you just explain either the thought process here or driving around town? Looks like the bulk of your power usage is coming from the motor. So just kind of explain how you come up with that.
So, yeah, go to the graphic. It's actually a chart for essentially a dyno graph for our parts motor that we were planning on purchasing. We used a lot of numbers off of this for basically calculating how much power the part is going to consume. Using amp draw and voltage that it's taking kind of out of watt hour for the estimation.
So is that like assuming a constant speed?
Yeah,
that you drive around?
actually, no.
Okay.
It's so an electric cart motor will only draw like maximum power from it as it's essentially accelerating. Once it reaches a top speed, that power kind of like plateaus out at a lower draw. So it would actually be using less power than what our chart is saying. That's a pretty overestimation of how much it's actually used. But it's not hard to estimate something like that because you don't know if there's going to be hills, if you're going to be using throttle the whole time, what speed you're going to be going. There's a lot of variability in the calculation. So we went with a really high power usage just to way overestimate versus.
Okay, so it's a big overestimation. Can we go back to that other table then?
Yeah.
So is that basically just this table that you're gonna show here? Is that basically just saying you're gonna run for an hour and a half at 25 miles an hour or something?
Similar,
Okay,
yes.
okay. So it's big overestimation. In White South Dakota, I think you probably circle the town about 100 times in an hour and a half.
Yep. And also, so with a lot of research, we found that the energy consumption rate for like an average golf cart is 0.06 kilowatt hours per mile. So then we just added a whole bunch of factors. Say you just want to make parts from it. So we had factor safety just for the energy consumption, which is what EV cars use for calculating the range. But like with a super large energy consumption, the 150 amp hour battery still gets 42 miles. So it'll last a while. Or it should.
Okay, so I think we're out of time for this team. If you have more questions for them, feel free to find them in the hallway or something. They'll be happy to answer more questions. So good job.